let's get into talking about hypothesis tests. We are just going to scratch the surface on this topic in this course, but we are going to try to explain the idea of it. And then once you start to understand about hypothesis tests, the context can change in other classes or situations, but the big ideas remain the same. And so again, this is part of inferential statistics. So we're trying to use the sample data to say something about the entire population. So here I am going to look at, let's go over here. It says let mu is a symbol for the mean of the population. Let mu be the mean pitch velocity. We wonder if it exceeds 75 miles per hour. What is an alternative hypothesis? So first of all, it's talking about the speed. Let's make a picture of the speed variable. So we'll insert a histogram of the speeds. And I'm going to pretty this up a little bit and make sure we include important information. So here are our speeds in miles per hour. This is talking about a count. I'm just bolding this. I'm bolding the chart title, which we will have baseball pitch speeds. Now, just to remind you, you can change the number of intervals. So if you go down and click on that horizontal axis and look for axis options, I'm going to click on the graph part. The number of bins, let's have the number of bins. I want to show you can change it. So let's just make it 15. So then it will change the number of bins. Let's look at the bin width, and the bin width, I like it to be sort of an integer. Let's have it be 4. Okay, so now we have a little bit clearer as far as reading. I just love and just want to remind you, you can do this. I love to put borders around the line, around the bars to help separate them. I think it looks really nice for the user. Okay, the last thing I'll do is just to remind you, we can put data labels. And maybe I will label in the center. Okay, very good. So now we have that there are 205 pitches in this 73 to 77 bin. Okay, we know that we should not be looking at this data set as a whole because there are definitely 3 different groups, and we're going to use that to motivate us in the future. But for right now, where we're just trying to get a handle on hypothesis testing, I say, we wonder if the mean pitch velocity exceeds 75 miles per hour. So 75 miles per hour is in here. Do I think the mean is bigger than that? I don't know. It sort of seems like it's in the middle. So I don't know that there's any convincing evidence to think that the mean is bigger than 75 from this histogram. Okay, so let's come up here and let's talk about the hypotheses. Hypothesis testing compares 2 different hypotheses. This is called H0, and that is the null hypothesis. And then H1 is the alternative hypothesis. Okay, and we are wondering, what does the data support? Does it support one hypothesis or the other? The null hypothesis is always an equal. So do we think that the mean actually equals something? In this case, it says 75. Or do we think it's greater than, less than, or which one is it? Now, this is not a possibility at all because equal to is in the null hypothesis. So the null hypothesis is a statement of no significant difference. So I think that the mean is not any different than 75. The alternative hypothesis is a statement of significant difference. So it's not going to be equal to. The null hypothesis is, I think that it just equals to 75. The alternative hypothesis is going to be that I think that the mean is actually greater than or less than, or let me see, I think we can insert a symbol, or not equal to. Okay, so the null hypothesis is boring. It's just, do we equal this? I don't think there's any significant difference. The alternative hypothesis is saying, or does the data say that the mean is greater than, less than, or not equal to 75? Okay, now for us, we wonder if the mean exceeds 75. So we're wondering, is this true? So this is our alternative hypothesis in this example. If the question was, is the mean significantly, do we think is the mean less than 75 miles per hour? That would have been the alternative hypothesis. And we could say, is the mean different than 75 miles per hour? Then it would have been this one, because this one's not making a choice of greater than or less than, it's just saying, is it different? So those are the hypotheses, and we already said it doesn't look like we should reject the null hypothesis. The null hypothesis says the mean is 75. And to me, it doesn't look like 75 is this like crazy number. So I'm just going to say it doesn't look like we should reject the null hypothesis. Okay, first of all, let's come down here to the conclusion. So the conclusion is either reject the null hypothesis or do not reject the null hypothesis. Just like in a court of law, the defendant is either guilty or not guilty. We never say innocent. So the question is, when we look at the data, does the data support this, so we reject the null hypothesis, or does the data not give strong enough evidence to reject the null hypothesis? Okay, now, is your test a one-tailed or two-tailed test? A one-tailed test is when the alternative hypothesis is greater than or less than, because we're just wondering about one side. A two-tailed test is when the alternative hypothesis is a not equal to, because we're interested in as long as we're different than, so we can be talking about two-tailed sides. So in this case, where we are having that alternative hypothesis, this is a one-tailed test. All right, now let's come down here. In the next video, we'll show you how to run a test, but for now, I've already run this test. So we have our t-test. Why t? Well, this is a t-statistic, which we're not going to get into why, but when you're doing hypothesis tests that involve means, you're going to have t-tests. So this is the statistic. The statistic is what comes from the data. So if we actually said, what column is our data in? C. So if we actually said, what is the average of column C, we would get that number. So the actual average is 75.6. Now this does not mean that supports my alternative hypothesis, because maybe that just happens by chance. If you took another sample, it might be 74. So the question is this bigger than 75 because truly the mean is bigger than 75, or is it just by chance? This is the sample standard or variance. We're not going to actually worry about that in this class. This is the number of observations. That's how many rows of data you have, often called N. Now, the test statistic it's going to be T if we're dealing with means. If you're dealing with something else, it would be something other than T, but in this class, we're just going to deal with T. Now, so our test statistic is 1.5959. What I want to say is that there's theory that says if you get a test statistic that is like bigger than 3 or less than -3, that's really unlikely. So the larger the test statistic is, the more unlikely it is to happen. All right, so now let's look at this. This P, this probability, is the p-value. Right. So this p-value is the probability of observing your sample data, assuming that the null hypothesis is true. And so what we're saying is about 5.5% of the time, even if the mean is 75, I would observe a sample statistic like 75.66. All right, so this is our p-value. We're going to write it again, but our p-value helps us decide if we should reject or not reject the null hypothesis. And we're going to see we're going to reject if the null hypothesis, if the p-value is less than 5%. Okay, if you have a p-value where it's the probability that of observing your sample data, if that's less than 5%, then what that means is it's unlikely that you're going to see that. So probably your null hypothesis is wrong. Probably the alternative hypothesis is true. So, if this was like 20%, we would say you're going to see test sample data like what you saw 10% of the or 20% of the time. That's not unusual. So we wouldn't reject the null hypothesis. So if this is small, we're going to reject the null hypothesis. And small, we're going to use a rule of thumb of 5%. Now, I don't really care right now about these. This is our one-tailed and two-tailed test. So if our test is one-tailed, we're going to be looking here. If it's two-tailed, we're looking here. Now notice this is a double that. One tail, the probability is 0.055. If there are two tails instead, you double it and you would get 11%. So we're going to be using this one. So for our p-value is going to be the one-tailed p-value. There we go. And that is a little bit aggressive, a little bit overwhelming. Let me just say 0.055. All right, What is the test statistic? The test statistic, again, we said is 1.59. Let me just copy this. And it's a t-value. And let me just say it's about 1.6. Now, again, if those are big, that means that they're more unlikely. That's not so unlikely. Should you reject the null hypothesis or not? Well, we are going to reject the null hypothesis if the p-value is less than 5%, and we're going to not reject the null hypothesis if the p-value is greater than or equal to 5%. So where our p-value is greater than 5%, we are going to not reject the null hypothesis. Now let's put the p-value into a statement. The p-value says, assuming the null hypothesis is true. Our p-value, remember, is 5.5%. So assuming the null hypothesis is true, the null hypothesis is that mu is 75. So assuming that the mean pitch speed is 75, the probability of observing something like you did, so observing a sample mean of 75.6, let me just copy that, or 75.7 if I round. So assuming the mean pitch speed is 75 miles per hour, the probability of the sample mean is 75.6, if I round it, 75.7 miles per hour, and this is our alternative, so or bigger, is that probability is 5.5%. Well, and that's bigger than 5%, so I'm going to say, you know what? It's likely that I would have seen it if the mean is 75. So I don't have any reason to reject that null hypothesis, so we are not going to reject it. So assuming the mean pitch is 75 miles per hour, the probability of seeing something like what you saw, so the probability that the sample mean is 75.7 or more, is 5.5%. That's the p-value. So what do? We don't reject the null hypothesis. I'm going to go with this. I'm not going to go with here. So the mean pitch velocity is not significantly greater than 75. The mean pitch velocity is not significant because we did a test, greater than 75 miles per hour. Is it greater? Is the sample mean greater than 75? Yes, but that's not significant. It could have just happened by chance. All right, that's a lot. We are going to rinse and repeat this a few times. That's all the new information. We're going to rinse and repeat it, and it will start to feel more familiar. I know it feels uncomfortable now. It will get better.